Right, this is going to be the first of 3 videos talking about different statistical tests that you need to know about in biology. And the 3 are going to be standard deviation, the student's t-test, and the Spearman's rank correlation test. So we're going to start today by looking at standard deviation. Now you probably have done this in GCSE Maths, but it may be slightly different. So I will talk you through a few of the subtle differences. So first of all, what is standard deviation? Well, standard deviation is basically a measure of how spread out your data is. So the greater your standard deviation, the greater the spread of the data. Now this might not be important, it might just be interesting, but it might be relevant if you are comparing 2 sets of data to see if there is an overlap or if one is more spread out than the other. Is that related to an experimental procedure? So it can be something useful to calculate. So if we look at a normal distribution curve, which again you should have come across before, within a population, whatever it is you are measuring, as long as it is continuous variation, for example height, mass, intelligence even, you will find that you have some people at one end, very few people at one end, a few people at the other extreme, these are our 2 extremes, and most people fall somewhere in the middle. This is a bell-shaped or normal distribution curve. Now when you calculate the standard deviation, from this data, you will see that 68% of the data lies within 1 standard deviation of the mean, 95% lie within 2 standard deviations of the mean, and 99.7% lie within 3 standard deviations of the mean. So if, for example, we took the height of everybody in school, okay, 99.7% of the people would be within 3 standard deviations of the mean, and Mr. Profit would be up here somewhere. So how do we calculate standard deviation? Well, you will be given an equation in the exam. Sorry, forgot this bit. This is basically just a little bit to show that things with small standard deviation, large standard deviation. Right, you'll be given this equation in the exam. Now this equation might be slightly different from the one that you have seen in maths before. As in, at the bottom, we use the value n minus 1. Often in maths, they use just the value n. But we have to use n minus 1. As I said though, you will be given this equation. So, what does this equation mean? So S, that's our standard deviation. Sometimes you might see it referred to this as the Greek letter sigma, but it's the same thing. Is the square root of the sum of x, where that's a value, minus x bar, that's the value in the data set, sorry, that's the mean of the value in the data set, squared, divided by n minus 1. So the best way to have a look at this and work this out is to have a look through a worked example. So let's start off with our first worked example. The masses in tons of a sample of 16 bull elephants from a single reserve in Africa were as follows. So we've got 16 sets of data. Okay, so the first thing we need to do is we need to arrange these sets of data into a table. So here are our masses. And then we need to work out the mean, so that's our value of x bar, of all of these sets of data. If we do that, it comes out to be 4.7. So then, in this column here, we do x, that's each of these values, minus x bar, so that's 4.7. So for all of them, it's the same value of x bar. So this is 4.6 minus 4.7, this is 5 minus 4.7, this is 4.7 minus 4.7, etc. And then you will get a set of data that looks like this. Ah, I hear you cry. but some of this data is negative, and that is why we square it. There's a lot of squaring goes on in statistics to give us positive values. So we then square all of these sets of data. Okay, so that will give us these values here. And then, so these are all these values squared, we then sum them. So we add up all of this data here, and that will give us a value of 0.76. We then take that data and we pop it into our equation. So our equation is the square root of the sum of x minus x bar squared. That's what we just worked out. That came out to be 0.76 divided by n minus 1. We had 16 bits of data, so n minus 1 is 15. And then we square root that, and that gives us a value of 0.23. So that is the standard deviation of that data. That's all you need to be able to do. We'll have a look at another example. Okay, work example 2. The length of petioles on 10 ivy leaves. We measure the petiole is the length of the stalk from the stem to the actual leaf. Okay, so they just measured all of this. So you can see we've got quite a big range here. We go down from 17 up as far as 57. Okay, so again, the first thing we do is we work out our mean. So that comes to 38.9. We then do individual sets of data, so x minus x bar. So we put all those in there. We square them. We sum them. So our number is 1994.9. Okay, we then pop them into our equation. That's what we've done here. And we end up with a value of 14.9. So we have a bigger standard deviation, so therefore a bigger range of data. All right, our data is more spread out in this set than it was in the previous set. So the time has come now for you to have a go at a question on standard deviation. The question is attached to the Show My Homework homework. I would like you to have a go at the homework, and then I would like you to send me through your answers. Either you can type them and email them back to me, or you can submit them via Show My Homework, or you can take a photograph and email it to me. Thank you.